So you're going to go to your y equals screen. If you want to do this on the calculator, you can do it by hand. You're plugging in 1 for x and seeing what the value is, and that's the limit as x approaches 1. Since it's a linear polynomial or whatever, a quadratic, it's going to give you a number. The problem happens when we start seeing fractions. That's when we're going to have problems. Now, if you plug in a 2 in this equation, you will notice that the basement turns to 0. That is a cardinal rule. Can't have 0 in the basement, right? But I'm going to look at the upstairs and say, I could factor that if I wanted to. So this is the same thing as limit x approaches 2. And what times what is negative 8 and added together is 2? It would be x plus 4 and x minus 2. 4 times negative 2 is negative 8. And 4 plus negative 2 is 2. Got it?
Wait, so you solve for x plus 4?
And then you've got an x minus 2. Now, when I graph this, the original question had a 0 in the basement, had an x minus 2 in the basement. But what's going to happen when I cancel these is that I'm going to end up with x plus 4. Okay? And it's undefined at 2, but as x gets really close to 2 but doesn't hit 2, it's going to approach 6. So you plug it into what's left. What is 2 plus 4? So in this case, as x approaches 3 from the right, and if it said negative 2 with a minus up here, it would be approaching negative 2 from the left. You see the difference?
Yeah.
So this is purely a graphing thing, and it's really easy. These are really easy to do, but make sure you pay attention. Number 11 has a minus sign in front of the equation. If you forget that, you're going to get the wrong answer, okay? And you have minus 3x. I like giving that minus to the upstairs, and then x minus 3 in the basement. So go ahead and put a parenthesis here and a parenthesis here. And I want you to graph that equation. Put that in your y equals screen. Negative 3x divided by x minus 3. So here when you graph it, 3 is an asymptote because we know that 3 is undefined. It makes the basement 0. So when I look at the graph and I want to see what happens when you're approaching 3 from the right, this graph goes down. So that means it goes to negative infinity. And that is your answer. If they had asked you what happens when you approach it from the left, it would be positive infinity because it would be going up here like that. So you have to just look at the graph for these. Well, we know infinity is a concept, really. It's not a number. What does infinity represent? What kind of number?
Any number.
What kind of number?
Infinite.
What kind of number?
A big one.
A big number. What does negative infinity represent?
A really small number.
A really negative number, really big negative number, which means you're in debt and you owe money to the world, and it's like the United States right now. Okay, so you've got a big number and a very little number. Well, you can't really plug in you can plug in big numbers into this equation, huge numbers, and see what happens. But sometimes you get into a little bit of trouble. So there is a simple way to do this algebraically, and I would like you to show your work. In case you do this next year, you can get some practice, okay?
Yeah.
So the biggest x I see in this equation is an x squared. Everybody see that?
Mm-hmm.
So I'm going to take everything and put it under x squared. And plus 2x over x squared. And plus 2 over x squared. I'm going to clean this up a little bit. You've got negative x over x squared would be negative 1 over x. You can't simplify anything on this guy. This guy here would be a 1 plus 2 over x plus 2 over x squared. Now you're at your grandma's house, and she's got your favorite apple pie. Okay? And we're going to cut it into a humongous amount of pieces, like billions and trillions and quadrillions of pieces, okay? How much pie are you going to get?
Nothing.
Hardly anything. Like if they cut it into like a quadrillion pieces, you're going to maybe get a crumb that you can't even see on your plate. Okay? So when I have, look at each thing individually. When I have -1 over a humongous number, that's really like a 0. That's like having 0. So this is a 0. When I have 3 over a humongous number squared, that's even closer to 0. All right? So this is 0. So you got a 0 upstairs. Downstairs, this is going to be 0, and this is going to be 0. So downstairs you have a 1. What is 0 over 1?
0.
That is the limit as x approaches positive infinity.
That's crazy.
All right.